In high school, you are probably taught that an experiment can only have one independent variable, or else it will be too complicated. Realistically, though, there are many variables that cannot be controlled, and more often than not, it is better to understand how the extra variables influence the outcome in total. I will discuss how a two-factor ANOVA, analysis of variance, helps us understand how two variables influence a dependent variable. Think about buying a car. Two factors up for consideration can be the price tag and fuel efficiency. This may not be a true experiment, but there are independent variables and dependent variables, the car selected being the dependent variable. Whenever a decision is being made, more times than not, there are multiple factors involved, such as the car example, or when deciding what apartment to move into. Utilizing a two-factor ANOVA provides an understanding of how two factors affect the dependent variable. Two factors can have a compounded effect in which they both greatly influence the dependent variable. It is also possible for the two variables to have no significant effect when both are in use. Just as important is to understand the individual amount of influence an independent variable has on the dependent variable. Understanding this provides a way to monitor the effect two variables have in conjunction. Take the car example. Sometimes the better car has a mix of a good price tag and fuel efficiency rather than the extreme of either. On the other hand, if someone is deciding to pick up a book, there might be a variable of great importance such as genre. This is to say that the factor of influence that a variable has may or may not be equal to others. Significant factors become important to determine as a way to establish the influence a variable has. Using this allows different groups to simplify problems by removing variables that are insignificant to an experiment. Let's take a simple engineering problem such as mixing concrete for a foundation. The engineers determine how much sand and water needs to be added per unit of cement to create an adequately strong foundation. Looking at the data, there is a noticeable trend that the concrete gets weak when increasing the ratio of either. Plotting these points onto a graph shows the relationship of these values and which ratio has a higher effect on the strength of concrete. Doing this allows analysis of one experiment rather than trying to analyze multiple experiments with one independent variable. Although much more detail can be put into describing the mathematics that goes into this analysis, the purpose was to provide a basic understanding of how a two-factor ANOVA operates.